Hello and welcome to this video is about binomial distribution, the probability of binomial distribution. We know what is binomial distribution at this moment in our discussion, but we're going to go ahead and take a practical example in order to show you how to calculate it both mathematically using a calculator or Excel. I prefer Excel in this case, or we're going to be using also Minitab, which is a powerful data and statistical analysis package that could be very helpful for you. Since I don't want to create anything from scratch, I'm going to be utilizing a very powerful, fantastic kind of website. It's called Math is Fun, which is going to actually be very helpful to provide us with some example already pre-made or question already pre-made. So I need to give them the credits for this, and it's a good website to visit if you would like to, not only for statistics, for other topics as well. So if you take a look at the general binomial probability formula, this is the number of x, the success out of the whole number of trials. It's going to be calculated as this, is n factorial divided by n minus x factorial multiplied by x factorial. This should be quickly reminding you of the same exact formula that we have done with combination. Combination is a topic that we always discuss with permutation. Combination when order is not a critical factor in our counting. So this is basically should not be completely stranger to you. That's multiplied by the probability of success raised to the number of x, and that's multiplied by the probability of failure when we take the probability from the 1, which is, as we all know, probability is between 0 and 1. That's going to be raised to n minus x, which means the number of the trial from the x, which is the number of we expected to be the number of success in our calculation. Also, I'm going to be discussing how to calculate the mean for the binomial distribution, which is going to be the number of the trial multiplied by the probability we're going to calculate from this formula. Variance as well is something that we could calculate as well, which is the sigma square. Very easy. If we know the mean, we only have to multiply that by the number or by the percentage of the failure as well. Notice that the standard deviation, if it was part of the question, it's actually the square root of the variance, as we all know. Let's take an example directly from Math is Fun and see how we're going to calculate this manually first, and then we're going to go to Minitab. The question asking is your company, if your company makes sport bikes, 90% pass final inspection, and of course what is left out of the 1 when we subtract 90%, it's going to be 10% fail, and those are the ones that need to be fixed. What is the expected mean, which is, again, this is the mean, which is going to be the number of n multiplied by the probability calculated for the success. And also, what is the variance, which is, again, this one here. Once we know the mean, we don't have to really reinvent the wheel also in the process of calculating the variance in order to get even maybe the standard deviation. It's just multiply the mean multiplied by the percentage, not by actually the value of the failure. If we have here the number of n is 4, because it says of the 4 next inspection. Sorry. First, let's go ahead and get ourselves familiar with the data that is giving. N is 4, the pass percentage, which is 90%. And now we're going to be able to look at the probability, which is the x is, of course, the random variable, which is number of passes from for inspection. Why we call it random? Because it could be 0, it could be 1, it could be 2, it could be 3, it could be 4. It could be any combination of cumulative values. For example, we say greater than or equal to 2, or more than 2, or less than a 3. Those kind of wording has to be translated into actual mathematical relation in order to understand what we are trying to find exactly. So if we take a look at the very first question, what is the probability of getting 0, 0 out of those actually going to be passing the test? This is nothing to it. As you notice, this is one more time the calculation the formula for calculating the probability. So in this case, x has become 0, and n is going to be always, in this case, 4. So x is 0, and n is going to be 4. Okay, I'm going to go ahead and make this a little bit bigger, so I'll be able to see it through the video. Here we go, even bigger than that. Okay, 18 is a good number here. So let's go ahead and calculate this. It's going to be p of, let's say 0. Sorry, here it's going to be 4. I made a mistake here. So number out of 4. And it's going to be 4. That's the number of the trial divided. And notice that I'm putting this into parentheses. So it's going to be 4 minus 0 factorial. And that is multiplied by the x factorial, which is in this case, it's going to be also 0 factorial. Remember, 0 factorial always going to be 1. Also, anything raised to the 0 power is 1. So now, when we talk about the p, which is 0.9, and that is raised to the power of 0, I'm using the exponents here in order to actually get this calculation copied into Excel, because Excel use the caret sign for exponents, and I use asterisk for multiplication. I'll have to adjust that a little bit. And this is going to be multiplied, so I'm using the asterisk here, of 1 minus 0.9, which is 0.1, raised to the power of, and n is 4 minus 0, it's going to be 4. So, okay, let's take a look at this for a second here. So I'll be able to do that actually manually, this one here, just a second. I have 4 factorial divided by 4 minus 0 factorial. What is 4 minus 0 factorial? It's basically 4. So, and that is multiplied by 0 factorial. So 0 factorial is 1. So the result from the denominator is 4 factorial. We have 4 factorial in the numerators divided by 4 factorial in the denominator. That is going to result into 1. So this is basically what we're going to be doing here. Just to go ahead and rewrite this, it's going to be 1, that the whole thing, multiplied by 0.09 raised to the power of 0 multiplied by 0.1 raised to the power of 4. So basically this is what I'm looking for, because I'm going to copy this as it is. Hopefully it's not going to carry some hidden character. I'm going to go to Excel and go ahead and see if that's going to be the case when I paste this, and immediately notice that Excel quickly calculated that for me, because Excel is a very powerful tool as well. I mean, way too powerful. And here we go. We're going to go ahead and do this. As you notice, 0.0001, and as a result, we could go ahead and do that as a percentage if we want. Because of course we have to show it's going to be actually very, very tiny, like 0.01 out of the percentage sign. Notice this is a very small value. If I wanted to go ahead and leave it as non-percentage, as a number in Excel, just to see if I'm going to get the same exact value in Minitab, as you will see. Just keep that in mind, what we got with Excel, and I'm going to go ahead and see if we can do that into Minitab in a second. So I'm going to show you here. This is Minitab. It's a very powerful analysis. I would like to go directly to the calculator there, and I'm going to go to the probability distribution. We have one fixed x, which is 0, and it's going to be 4. The probability is going to be 0.9. So I'm going to stick all these values in the calculator here. I'm going to go to the binomial, and I already have it for, okay, that's for the event probability 0.9, which is the success. And the input constants, because I'm not really getting the value from columns here, I'm getting it directly from constants here. So it's going to be 0. And if I run this, you will see at the number of trial is 4 with the success probability of 0.9. And I wanted to get 0 passing that test. X, which is 0 in this case. If you run it, look here, it's exactly what we did actually manually. So 0.0001, of course, you could change this to a 0.01%. That's going to be more meaningful when you're trying to present the value, which is a very tiny 0.01% chance of no passes. Now, what about if I say to you, what would be the percentage of passage, or the probability, sorry, not the percentage, of x is equal to 4? So we wanted to get exactly 4. Again, this is very, very easy to do in Minitab. We're going to go to the calculator. We're going to go to the probability distribution. We're going to go to the binomial. And we're going to go ahead and get that 4 changed to still in is 4. Still is the event probability of success is 0.9. But now we're actually increasing the number of x from 0 to 4 in this example, or changing it from 0 to 4. If you notice here, wow, this is a very, very high successful rate in my opinion, which is going to be 65%. And multiply that by 100 to get the percentage, 65% of a chance they all pass the inspection, which is 4 out of 4. So that's good. What we could do here in order to even see a different flavor of how we use it in Minitab, we could really look at that graph. That will help us even better to see things graphically. So I'm going to go to the graph just to add more meaning to the calculation, also to get practice with Minitab. I'm going to go to the probability distribution plot. There we go. I'm going to choose, since I'm going to actually get a color, I'm going to choose view the probability. Okay, I'm going to say okay. And notice here, I'm going to, the distribution here has to be changed to the binomial. It's defaulting to the normal here, but binomial B is way up in the alphabetical order. And now the number of the trial is 4. We could get the 4 basically, or the 0 in our example. Let's get both. So event probability is 0.9. Okay, is that clear? And we're going to go ahead and go do the shaded area. And in this case, it has to be the middle because we're looking for exactly that number of x value, which is, I'm going to go ahead and change it here. And it's going to be, in this case, let's start with 0. We'll do it with 4. And if you look here, click on it again. Sorry, we have to do both values 0, 0, as you notice, because this is a constant value. We're not doing any accumulative greater than or less than. So I'm going to go ahead and look at this one here. It's going to be very, very tiny even for us to show as part of the bar because it's extremely small. Let's go ahead and minimize this. And I'm going to go ahead and do the same thing for 4 at this time. So we're going to go to the graph. And we're going to go to the probability distribution plot. And I'm going to go to the view probability one more time. Take your deep breath and see the step 1 second at a time in order to understand how to repeat this. So we're going to go OK. Okay. And I'm going to change the probability of the binomial because the last time I did it, it was binomial. So the number of the trial is going to be 4. And the event probability of success is 0.9. Now we're going to go to the shaded area. I'm still looking for an exact value or constant value. So I'm going to choose the middle for the shaded area. Now, x also, you need to make sure that the x value is the one that's being chosen here. And as a result, we're going to go ahead and put 4, 4, and also 4 out of this. And here we go. We're going to choose. And notice, this is exactly what we got through the calculator. And if you use Excel to do the formula, the longer way of calculating, we'll get this. But this is exactly 4. What about if I say to you, I wanted to get everything is greater than 2, the probability of getting x greater than 2. So when we say greater than 2, we're not including 2. So it has to be, in this case, greater than or equal to 2 is exactly like saying greater than or equal to 3. So the probability of getting x as greater than or equal to 3, meaning the success of passing the test more than or equal to 3 times, it would be now multiple values or a range of values, so or a cumulative number of values. So let's go ahead and see how we're going to do this. Okay, first of all, I'm going to use the calculator for this because it's really going to help us a great deal. So when we talk about the graph here, I'm sorry, the graph, not the calculator, it will not only give us the value, it will give us also that graphs and give us also a better graphical representation of these values. So we're going to go to the probability, and I'm still going to use the view probability. Okay, well, here you have to really take your time to understand what's going on. It's still binomial, of course. The number of the trial is still the same for the event probability. It's still the same, is 90%. Now with the shaded area, we're looking for greater than or equal to 2. Greater than 2 is the same thing as saying greater than or equal to 3. I'm sorry, greater than or equal to 3. Greater than 2 is meaning greater than or equal to 3. Because the opposite of greater than is less than or equal to. When we actually saying greater than 2, that means anything is anything that larger than 2, and this is going to give me a 3 and greater than 3. So I'm going to be using the right tail in this case, and the value will be 3. So this is going to be exact translation of anything greater than 2. And look here what's going to happen in a second. Notice it's incredibly high percentage in my opinion, 94%, which is going to give me the success of all the trial when x is greater than 2 or greater than or equal to 3. So this is a fantastic way of looking at how that graph could be done, not only to get the value, but also to get actually a kind of similar to a column chart to represent that value and give us a good image of it. Thank you for watching this video. I know it's a very long one, but hopefully it's going to give you a better understanding to do some binomial using Minitab more than anything else. But you can do it also manually based on the probability and formula. And if I wanted to go ahead and do the for this value, I could go ahead and grab it. This is where 0.9477. I could very easily go ahead and calculate the mean, which is going to be this value multiplied by 0.9. If I want to do the variance, it's going to be after I find the mean, I will be multiplying that by 0.1 for any sort of probability calculation, for any sort of binomial distribution calculation. It doesn't matter what is the problem asking for us. The mean is always going to be in P, in number of the trial multiplied by the probability that you calculated, and the variance is going to be the number of the trial multiplied by the probability you calculated multiplied by 1 minus p, which is actually the probability of failure. Thank you again and have a great day.